Okay, so factoring and solving polynomial equations. So if you have you know how to factor general trinomials where it's like 2x squared minus 3x minus 20. We've worked on this. What multiplies to give me negative 20 adds to give me negative 3 with a leading coefficient of 2. You also know how to do perfect square trinomials. X squared plus 8x plus 16 is just x plus 4 squared. You know how to do difference of squares. 9x squared minus 1, so it's 3x plus 1, 3x minus 1. And you know how to do perfect or common monomial factors where we factor something out. So like 8x squared plus 20x equals 4x times 2x plus 5. Okay? So a factorable polynomial with integer coefficients is factorable completely if it is written as a product of unfactorable polynomials with integer coefficients. Meaning 2 times x plus 1 times x minus 4 and 5x squared times x squared minus 3 are factored completely. I can't take anything else out of x plus 1 or x minus 4, and I can't take anything else out of x squared minus 3. They're factored completely. Okay? 3x squared times x squared minus 4 is not factored completely. Why is it not factored completely? X squared minus 4 is a what? No, it's a difference of 2 squares. So that would factor to x plus 2, x minus 2, yes? So the true way to factor that completely would be 3x times x plus 2 times x minus 2. So what we're going to focus on today is factoring everything completely. Okay? X cubed plus 2x squared minus 15x. What would I do to factor this first? What would you want to do first? Take an x out. Okay. Let's take an x out. If I take an x out, then I have x squared plus 2x minus 15. Is that factored completely? Does something multiply to give me 15 add to give me 2? What? 3 and 5. Which one's positive? Which one's negative? 5 is positive, 3 is negative because this is positive. Now, is this factored completely? Yes. So we're going to stop there. Did they send me a pass, Abby, or did you?
I sent one to Miss. It's
Beautiful. Okay. So then you have 2y to the 5th minus 18y cubed, yes? What factors out of 2y to the 5th minus 18y cubed? Two y what? Not y squared. Y cubed. 2y cubed. Okay, so let's factor out a 2y cubed. And you are left with y squared minus what? 9. Is that factored completely? Y squared minus 9? No, it is a difference of 2 squares. So you get 2y cubed, and then it should be y plus 3 and y minus 3. Is that factored completely? Yes. So do you see what we're doing today? We're just factoring, factoring, factoring. Okay. 4z to the 4th. You're going to get lots of examples today. Minus 16z cubed plus 16z squared. What can we factor out of all of those? Yeah, 4z squared. If I factor out 4z squared, I'm left with z squared minus 4z plus 4, correct? Is there something that multiplies to give me 4 and adds to give me negative 4? 2 and 2, negative 2 and negative 2, good. So 4z squared, and then I can say z minus 2 squared, right? Because there's 2 of them. Z minus 2 times z minus 2. And that is as far as I can take this. Okay, so the first section of your homework is simply factoring. You have to factor something out, and basically what they're telling you is you're going to continue to factor. Something is going to factor out, and it's not going to stop there. Okay? Special factoring patterns. You have to memorize these patterns, just like we had to memorize them when we multiplied them out. Okay? The sum of 2 cubes. The sum of two cubes says if I have a cubed plus b cubed, it's the same as saying a plus b in parentheses times a squared minus a times b plus b squared. So 8x cubed plus 27. I take the cube root of 8 and the cube root of x cubed, and you get 2x. You take the cube root of 27 and you get 3. 2x plus 3 is that first set of parentheses. It's my a and my b. Then I take whatever this is and I square it. 2 squared is 4, x squared is x squared, so 4x squared. Then you take these two things and multiply them together. 2x times 3, and you get 6x, but it's going to be a minus. That's the pattern. It will always be a minus in that middle section, because that's how it cancels out to just give you an end and a beginning and an end. And then this part is 3 squared, which is 9.
Power on.
Is your project going to talk to me today?
It's gonna play music.
Okay.
Here's the music.
No, we're going to putt-putt today in Nathan. It's going to be fun.
And she wanted to tell you that you get hot chocolate.
Oh, well, she gave me a gift. Is that what's in it?
Oh, I don't know.
She wrapped a gift and said it's for me and Ashley.
Maybe.
Okay, well, I like presents, so.
Okay. That's why there's whipped cream in your fridge.
Wow. Okay, then you have the difference of two cubes, a cubed minus b cubed, okay? It's the same pattern as the sum of two cubes, except for this sign and this sign change. Okay, so now it's going to be minus in this a minus b, and it's going to be plus where the ab is. Okay, same exact pattern though. So if I have 64x cubed minus 1, what's the cube root of 64 and the cube root of x cubed? Cube root of 64 would be, 4. Because 4 and 4 is 16, and 16 and 4 is 64. So 4x goes here. Cube root of 1 is 1. People always mess that one up because they don't recognize that that's a perfect cube or a perfect square, and they forget. Okay, don't forget. 1 is a perfect cube and a perfect square. 4x minus 1. This part becomes this squared. So 4 squared and x squared gives you 16x squared. This part becomes this times this, and it's the opposite sign. So 4x, and then this becomes this squared. Negative 1 squared is 1. Okay, those two patterns you have to memorize, because I'm not going to allow in your test enough time to factor those all the way out. I'm going to assume that you've memorized the pattern, which shouldn't take you long to factor out then. Okay, so here's plenty of practice for us. Okay, x cubed plus 64. So since that has a cube with it right there, I'm going to assume that 64 has a cube root. I'm going to check for that first. That's my clue. So does 64 have a cube root? What is it? 4. So my pattern says take the cube root of this, add it to the cube root of this, multiply it by this squared, minus these two multiplied together, plus this squared. That's how I factor that. You see what I did there? Okay? I just make it that simple. If you have the pattern memorized, it makes it that simple. What are you looking for, Chica?
That thing.
That rule with me. So then I have 16z to the fifth, right? Minus 250z squared. What can you factor out of there? The z, how many?
Those.
2, because this is the power that tells me. So z squared, and you get 16z cubed minus 250. Now, I know that z cubed is a perfect cube. Is 16 a perfect cube? No, but what is 16 divided by 2?
Yeah, you could have taken 2 actually.
You could take what out, Peyton, from the
2
beginning?
there.
I can take a 2 out from the beginning also. So if I take a 2 out from the beginning, this becomes 8, right? And what's half of 250? 120. 250 divided by 2 is 125, right? Okay. Is 8 a perfect cube? Yes, 2 times 2 times 2 is 125, a perfect cube. Well, what number would you think it would be if it was?
It is 5.
5. So if I take 125 divided by 5, I get 25. So yes, it's a perfect cube. So now, what's my perfect cube pattern? What goes here? What's the cube root of these two things? What? 2z. And then it's minus, because that's a minus, and it's minus 5. What goes in this second spot? It's this squared. What's 2z squared?
4z.
Good. And then it's plus, and what are these two multiplied together? 10z. And then it's plus, and what's negative 5 squared? 25. Boom. That is now factored. Okay. I gave us a lot of practice on this one. So let's practice this. X cubed minus 7x squared plus 10x. Now these ones are mixed together, so you have to think. Is there anything I can factor out of all of it? That's the first question you ask yourself. Can you factor something out of all of it? An x. And then that means you're left with x squared minus 7x plus 10. Is there something that multiplies to give you 10, adds to give you negative 7? Negative 2 and negative 5. Can I factor that at all anymore? Nope, boom, answer. Okay, next. Okay, here we go. What about 3y to the 5th minus 75y cubed? Can I take something out of all of it? 3y cubed, good. I can take 3y cubed out. I'm left with y squared minus, what's 75 divided by 3? Is it 25? Yeah. What do you notice about this? Perfect, a difference of, so y minus 5 and y plus 5. Now do you see why we need to have all these rules memorized? Because it makes my life easier than trying to sit there and factor things out. Okay? You have to have these rules memorized. 16 b to the 5th plus 686 b squared. Boy, that's a fun one. I would start by seeing if 16 goes into 686, just to try it out to see if that helps us at all. So if I take 686 and divide by 16, it does not go evenly. But let's see if 686 can be divided by 8, because I know 8 goes into 16. Nope. But I know, what else goes into 16? Just 2 and 4? So let's try 4 into 686. That's a no. And let's try 2 in, and it will definitely go, yes. 343. So we're going to take out a 2 what? Good, 2b squared. And you're left with 8b cubed plus 343, yes? Now, does this have a cube? Does that probably then? How can I check on my calculator to make it easier on myself?
3
Yes,
second.
caret. Yeah, so tell me if it has a cube root for me. Their calculators are over there. Oh, okay. So 343 should break down into 7 times 7 times 7. Okay, that's my hint to check for a cube. So now I have to do it in that special pattern. Plus, minus, plus, right? What goes here? 2 what?
2b.
2b. What goes here? 7. What goes here?
4.
4b squared. What goes here?
14b.
14b. And what goes here? 49. Now, can this be factored any further? Can that? No, I don't think it can. so we leave it like this. Okay? The cube root of 8 is 2. Now, let's try w cubed minus 27. How does that factor out? Yeah, perfect cube, okay? Cubes, perfect cubes. So I have this minus this, and then I have this plus and plus, yes? What goes here? W. What's the cube root of 27? 3. What goes here? What goes here? 3W, and what goes here? Boom. You must beat these patterns into your head. Honey, there are 8 slides. Factor by grouping. Okay. If you have 4 things in a group setting, okay, 4, we're going to have to do some type of factor called factor by grouping, okay? So if I have x cubed minus 3x squared minus 16x plus 48, the way I factor this is I group these first 2 together and I group these second 2 together, okay? What can I take out of here? X cubed minus 3x squared. What can we take out of here? What, Jackie? An x squared. I can take an x squared out. So you're left with x minus 3. Okay. You see how I'm left with x minus 3 now? I want this same thing over here when I take something out to make it say x minus 3. So what would I have to take out of negative 16x plus 48? What would you have to take out to get it to say x minus 3? Because if it doesn't say x minus 3, this is not factorable. I'll tell you that right now. What's 48 divided by 16? Is it 3? So I'm going to take out a negative 16 because I need it to say x minus 3, not plus. So if I take out a negative 16, that changes my signs to this, yes? Now, here's the tricky part, and this is what people usually mess up. These 2 things come together to make 1 unit. These 2 things are the same. They repeat. They're called repeating factors. So we don't need to represent them twice. We're only going to represent them once. With x, no, you are not putting a square. You are only representing it once. They become 1. Kind of like when you're taking the square root of 4. What do you get when you take the square root of 4? 2. Do you represent it twice? No. Basically, I took the square root of these. That's what I did. Okay? Now, can this be factored further? X squared minus 16.
X.
Because it is a difference of squares. X plus 4, x minus 4. Can x minus 3 be factored any further? No, so you get x minus 3. Now look, this is a cube function, yes? How many answers do I have? 3. How many answers should I have? 3. Okay? That is how we factor polynomials when there are 4 things to it. It's by grouping. Okay? We factor by grouping. These are factoring polynomials in quadratic form. Okay? These ones are pretty simple. Look at this. If you have 16x to the 4th minus 81. What do you know about 16 and 81? Perfect squares. Is x to the 4th a perfect square? Yes, so this should factor to 4x squared minus 9 and 4x squared plus 9, correct? Now, what's this? Difference of squares. So you get 2x plus 3 and 2x minus 3, and here you have 4x plus 9 because that can't factor any further, right? Because it's not a difference of squares. Not a difference. It can't factor any further, just trust me. It won't work. Here are your solutions. Look, 1 solution, 2 solutions. How many solutions would be here? If I set 4x squared plus 9 equal to 0, you would get 4x squared equals negative 9. You would get x
You would
squared.
get plus or minus those two.
Correct. So I have 4 total solutions. Okay, good, Kaden. Okay, try the next one. Like I said, we have lots of problems today, yes. My theory is, the more examples, the better for you. 2p to the 8th plus 10p to the 5th plus 12p squared. Can I take something out of all of that? 2p squared. So 2p squared. You're left with p. What if I take 2 out of this, what do I get? P to the what? 6. Plus 10p cubed plus, oh, not 10, I'm sorry. 5p cubed plus 6, correct? Anything multiplied to give you 6, add to give you 5? 1 and 6. So this breaks down into p cubed plus, 1 and 6 do, but that won't work because that would give you 7 if you add them together. So how about 3 and 2? And then p cubed plus 2. There you go, we have it factored. Okay, this one. What are the real number solutions of the equation? 3x x to the 5th plus 15x equals 18x cubed. What do you think we need to do to start to solve this first? What do you need to do?
Guess the letter C.
Get what?
Guess the letter C.
How about get everything set equal to 0? So it should say 3x to the 5th minus 18x cubed plus 15x equals 0, yes? What can I factor out of all of this? 3x. So then you get x to the 4th minus 6x squared plus 5, yes? Something multiplies to give me 5, adds to give me negative 6. One and 5. Both have to be negative. That will give you a positive. That will give you a negative. What's this? Difference of squares. Yeah, difference of squares. So it factors to say x plus 1, x minus 1, and then this is x squared minus 5 equals 0. They want to know what are all the real zeros. So you take 3x, you set it equal to 0, and you get x equals 0. You take x plus 1, you set it equal to 0, you get x equals negative 1. You take x minus 1 equals 0, and you get x equals 1. You take x squared minus 5, set it equal to 0, you get x squared equals 5. So you take the square root of that, and you get x equals plus or minus radical 5. So my zeros are 0, negative 1, 1, and plus or minus radical 5.
Should have gone with my gut.
It would be D. That is what you are doing today.
We only had 7 slides here.
You do only have 7.
Can I see a picture?
You can take a picture.